All right, so welcome back to Pre-Calc. So we're going to talk about hyperbolas today, and hyperbolas are kind of neat. So here's what a hyperbola is when you have that cone, it's a little bit different than the rest of them because there's always two. They always come as a pair, right? So we take a slice this way, so you're going to be getting something that looks like this. Or, right, here's your axes. Or you're going to be getting something that looks like this. Okay, now with a hyperbola, your focus is going to be outside of the curve. Okay, focus. All right. And the idea is the one that is the negative variable is the one where it doesn't exist. Okay, if it's the real part, the positive one, that's where you're going to get your curve. So if it looks like well, let me give you the general form here, as it is an x, technically minus h squared over an a squared, minus a y minus k squared over a b squared is equal to 1. So the center, right, is still hk. Okay. Or, right, you could have it as y minus k squared over b squared minus x minus h over a squared is equal to 1. Now, it doesn't really matter, b over b. I mean, it tells you how, the shape of this thing. But it doesn't really matter like which one is positive or negative. Again, the x with a y, if the x one is positive, x term is positive, that would be this case. We're going to get something like this. Okay. If the y term is positive, we're going to get something like that. Okay. Okay, and neither of these things are functions, right? They all fail the vertical line test, so they're not functions. You technically neither are circles or ellipses, but parabolas can be. We can have parabolas going this way though, so that's not a function either. But that's okay. It's conic sections. And the real key to being able to graph a hyperbola is drawing the box. And I will show you that in the first example because that's kind of the key to doing all of this. Once you have the box, you have the whole thing. Okay. Okay. Actually, I really would like to graph this thing rather than have that. There we go. Okay, perfect. So it's also a much nicer problem because with the ellipses where we used method of intercepts, we're going to be using method of intercepts here as well. So it's the same kind of thing, it's just a little bit different. All right. Let's see here. So we have an x squared minus over 49 minus a y squared over a 64th. This is equal to 1. So we use method of intercepts. We set y equal to 0. We get x squared is over 49 is equal to 1. X squared equals 49, so x is equal to plus or minus 7. Okay. We're going to set x equal to 0, but we're going to ignore this negative. Okay, so we're just going to have y squared over 64 is equal to 1. So y squared is equal to 64, or y is equal to plus or minus 8. Now, technically, it's 8 plus or minus 8i, right, because of the negative here. But that's how you could tell, like, well, which direction does it go in? It goes side to side because even if I didn't ignore the negative, right, this would be a real solution. But if I didn't ignore the negative, this one would be an imaginary solution. So I know it's not up or down because this coordinate doesn't really exist on my xy plane. Okay, but that's how I always remember it. Is like, well, if I did this with the negative, we'd end up with imaginary numbers and we can't graph those. So that is not a place where the hyperbola actually exists. Okay. So I mentioned the box. Okay. So in order to graph this thing, right, the center is at 0, 0. So what we're going to do is we're going to mark this out. We're going to say, okay, well, this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I wish I had a little bit better of a way to graph this to be a little bit more accurate, because sometimes it actually matters. All right, so what we're going to do is we're going to make a box. We're going to take all these little intercepts here. We're going to make our box. Yeah, 1, 7, and 1, 8 in this case, so it's really close. Now, there is a point, there is 2 points at 7 and 0 and -7 and 0, right? 7 away from the center, boom. -7 away from the center. And then what we do next is we go ahead and we draw these asymptotes between the diagonals of the box. I should have put these in a different color. It's not going to erase very well. Okay, let's go ahead and try it. Let me do a lighter color here. Not that light. That's good. So we're going to have asymptotes. Okay, and then to draw this thing, okay, all we're going to do, and go from the vertex here, and we're just going to kind of hug in our asymptotes to be able to draw this. All right, and this is how you draw a hyperbola. Okay, and it doesn't matter if it goes up or down or not. One of the questions they're going to ask you is, what are the equations of those asymptotes? I guarantee you that is one of the things they're going to ask is, what are the equations? This is why it is really nice to have a center at 0, 0, because I know my intercept, the b in both cases for both asymptotes, that y equals mx plus b, that b is 0 because it goes through the origin. In order to get the other asymptote, well, everybody asks you, like, what's slope? You say, it's rise over run. Like, great, what's the rise? It's 8. What's the run? 7. How about this one? Well, in this case, the rise is -8, but the run is still +7. So here are the equations of your two asymptotes. All right. Now it gets a little bit more difficult when it doesn't go through the origin. If you happen to know what the intercept is, you can just write down plus b, whatever that happens to be. But usually it's not going to be around that. So you're going to have to do like a, you're going to have to pick a point that it does hit, and do this thing. Right. Use the slope intercept form or the point slope form. Okay. There is another way to do this with y equals mx plus b. I'll show you that when we get to one that requires it. But pretty much all you do is if you know your slope and know your x and your y, then the only variable left to solve for is b, and you can do it that way. Okay. So how about we go ahead and do this one? Okay, the center 0, 0. All right. Now I'm going to admit I don't know. Oh, they didn't ask. some of the words they use, like the transaxius and they use the proper words for the different axes, and I don't use them often enough to really know what they're supposed to be. So we're both going to learn this together. But -7, which means I'm never going to ask you that either. Okay, I'm not going to put the formation like that. I'm just the question I'm going to ask are things like graph it, tell me the equation of the asymptotes. Okay, now the foci, again, I do not have a problem providing you with this information. Okay, so if I'm going to ask you a question about the foci for a hyperbola, c squared is equal to a squared plus b squared, just like Pythagorean. Okay, notice with the hyperbola, okay, okay, the focus is outside of the curve, right? It's a little bit more than the curve, but with an ellipse, c squared is equal to a squared minus b squared, and they were right. They were inside of the curve. Okay, so if the foci were down here somewhere, right, I would know that first off that's not right, but secondly, you know that they have to be outside because it's a little bit bigger, right? The plus, it's adding to it, making it bigger. This one's a minus, it's bringing it back. Okay, so that's one way to remember it. But like I said, I'm never going. If I ask you foci, I will tell you. Here's the formula for it. So again, it's just the big one and the little one. We're just going to add them, but in this case, it doesn't even matter, right, which one it is. So we're just going to get 64 plus 49. Add those together. What are we ending up here? We're ending up with like 113. Okay, 15. Yeah, it's that. Is equal to c squared, and c is equal to plus or minus the square root of 113. I don't think 113 is factorable. Okay. So where are the foci? Well, in this case, right, my vertex was -7 and +7. The foci are going to be in the same line as the vertice. Okay, so this is going to be plus root 113, 0, and minus root 113, 0. Okay, so that's what we do for that one. So 3, hopefully it will tell me this could be simplified. Jeez. Okay, so I'm hoping that's not the case. All right, the equations of the asymptote. See, go figure. It's exactly what I'm going to ask you too. Is what are the equations of the asymptotes? 8/7 negative 8/7. Okay. So if it's not centered at the origin, then we're going to have to go through the rest of that. Okay. And then they're going to ask us to graph it. Okay, so we'll go ahead and we will come up with a point here. 7, -7. Okay. And let's see, place the center, place the vertex, right? Placing the asymptote. So when x is 7, right? X is 7, then y is going to be 8. Yeah, I think we're good. All right, and that's all they wanted, right? Oh, let me try again. 8/7. I'll place center, okay. Vertex, it's at 7 and -7, so we're okay there. And then place an asymptote. It's going to be a 9. I don't know. What did I not? I have no idea. Okay, well, I don't know. They look pretty close, but maybe I didn't get the corner exactly right or something. So I'm just going to assume maybe I should plot the point next time. So, all right, not going to worry too much. All right, so let's see here. Do we want to do, we should do one like this too. Okay. This could happen with ellipses as well, by the way, where you don't get the whole number underneath. You kind of do, right? 4 over 25 is equal to 1 over 25 over 4, right? Is a reciprocal. Over 25 here. So really what's going on here is this x squared, 4x squared over 25 minus 16 over 81 y squared is equal to 1. See, the nice thing about this is that the method of intercepts still works for us, okay? So if I was just trying to graph this, right, set y equal to 0, we have 4/25 x squared is equal to 1, x squared equals 25 over 4, x is equal to 5 over 2. Okay. Set x equal to 0 and ignore negative. Okay. Now, it's going to be a little bit tricky when we get to the a squared and b squared. Okay. So we have 16 over 81, y squared is equal to 1, y is equal to 81/16, and y is equal to plus or minus 9/4. Okay. So we have a 5 halves and a 9/4. Now, when I get down to the foci here, okay, the vertices, those are easy, we just did it. Foci, now, remember their A was just what was underneath here, right? When we did that, the A was just what's underneath. And here we have 4x squared over 25. That's really x squared over 25/4. Okay, so minus y squared over, right, 81/16. So here is where we're going to have to deal with the fact that a squared and b squared are going to look like this rather than just pulling off the bottom number. Okay, so this is the only thing that's a little bit different. Okay, but just remember to make it x squared over something, y squared over the other thing, and it's going to go okay. So in this case, center still 0, 0, right, 0, 0. All right. Vertices, that's going to be, right, negative 5 halves and 0. And then positive, oh, come on, 5 halves and 0. Foci, see, this one's going to be a little changed. So we still have our c squared is equal to a squared plus b squared, but it's going to be 25/4 plus 81/16 is equal to c squared. That's going to give me 100/16 plus 81/16. So we get 181 over 16 to be c squared. Now I know that 3 goes into 181, I think. Nope, that doesn't. I should have added up to 9, not 10. Okay. I don't know if 181 is a prime or not. Somehow I doubt it, but we're going to go with that. C squared. C is equal to plus or minus root 181 all over 4. Okay, and again, we're in the same line as the vertice. Okay, since the vertices were just on the x-axis, we're just going to say, okay, well, this was 181 over 4, 0. Here we have negative square root 181 over 4, 0. Okay. And we'll check our answer. Okay, I've got to check on something because that started without anything else. All right. Find the asymptotes. So in this case, right, if we were gonna graph this thing, right, we go out about 1, 2, 3, 5 halves, 1, 2, 3. 5 halves is a little bit less than 6 halves, which would be 3. So 5 halves I know is 2.5. And then our y's are 9/4. Okay. Doing laundry, if you have 8/4, you have $2. 9/4 is going to be a little bit more. All right. So we have our little box here. All right. And then we will go ahead and make our little asymptotes. Again, they go through the center because the whole hyperbola is centered at the origin. So that's nice. And then when we go ahead to graph this thing, we're going to end up with I know, I'm sorry, all of my graphs look almost exactly the same. All right, so there we go. Let's see here, we have. Okay, so what is my slope here? Well, the slope is going to be the rise, which is going to be 9/4, over the run, which was 5 halves. Okay, and I know a lot of people haven't seen this since intermediate algebra. We've got 9/4 divided by 5 halves. That's one way to do this. So 9/4 times 2/5. Right, we have a 2 there, so we end up with 9/10 as our slope. Or positive or negative, right? Because we could have gone this way. All right, so we end up with, I could say 0.9 really too, couldn't I? 9/10 x and negative 9/10 x. Okay. So check my answer here. Very good. Okay, now we're going to have us draw it. All right, I'm going to make a couple of points before we start. Okay, so I want to graph things. I want to graph 5 halves and 9/4 because I don't want to fight with that again. All right. All right. So let's see here. Oh, I want to graph negative 5 halves and 0. So when it asks me for the vertice, I'll know where that's going to go. All right. So where's the center? Boom. Vertice, we are going to place that right there. And then our asymptote, I'm going to place that right there. And we'll see if we do any better here. All right, much nicer. Okay, so if you're running into problems with graphing these things, I recommend like plot a couple of points first and then go ahead and finish it because it's really not, it shouldn't be that hard. But yeah, it's going to make it. The computer will make it that hard. All right, do we have one? Oh, this is a beautiful problem. Okay, this one's good. I will absolutely give this to you. Okay. Don't let me fool you. One of the first things you always have to do with a hyperbola is put it in the proper form. You have to do that with ellipses, you have to do that with circles, you have to do that with hyperbolas. Parabolas, not so much because you have a lot of practice graphing parabolas. But what we're going to do is we have to divide everybody by 4,900 first. Negative 4,900. Right? Which is 49, right, times 100. Okay. So we're going to divide everybody by that first. So here we get 1, which is what you should have. Okay, this is This is non-negotiable. This has to be a 1 here. Negative over negative turns it into a positive. The 49s cancel, but we're still left with 100. And in here we have minus y plus 3 squared. And again, the hundreds cancel, so we're left with 49. Okay. So it's still a nice problem because we have some, excuse me, we have some perfect squares. Okay. But now it's not in the center. And you also notice that they kind of flipped, right? If it was going to be a side-to-side thing or a top-to-bottom thing. Because they did this. Okay. So again, don't let them fool you. Don't let them trick you. We're better than that. So in this case, let's see. We have pluses and pluses. We do. So my center. Okay. -4, -3. Same idea as we had for all the other, for the circle and for the ellipse. The negative belongs to the formula x minus h. So x plus 4 is x minus -4. Okay, so there we are. That's our center. B. For B. Identify the vertices. Oh, well, not quite. So here, right, set y equal to -3. So this whole term goes away. So we have x plus 4 squared is over 100 is equal to 1. And then just solve. Take the square root. Okay, so we have x plus 4 is equal to 10. X plus 4 equals -10. I don't understand. Sorry. -4, x equals -14. Okay. So you can see where it's a little bit offset. By the way, what was y when all this happened? Right? What was y? Y was -3. So my vertice is at 6, -3, -14, -3. Okay? I have no idea what's going on today. All right. So identify the vertices. We've done that. Foci. This one's not going to be as bad. Foci c squared is still equal to a squared plus b squared. That's 100 plus 49. Hold on, I've got somebody at my door. It's amazing. It's Tuesday. All right. C squared is just equal to the sum of these things. Sorry about that. C squared is equal to 149. So C is equal to the square root 149. That is not a perfect square. That's not anything. So it's in line with the vertice. It's on the same line. So my foci are going to be at negative, well, I'll do the positive one, 149 square root, okay, -3. And then we're going to have positive square root 149, -3. Okay, so same line as the center. All right. What else did they ask us for that? Oops, wrong one. There we go. All right, foci. Then we're going to have to write equations for the asymptotes. Here's where it's going to get interesting. Okay. So when I draw my little box, okay, the rise and the run, right? We're still 10 and 7, right? Right, because we're still going to draw this black box. It's just going to be from the center point, okay? So it's still 10 in either direction. It's just 10 from -4. And here's so the slope, right, is still going to be the rise 7 over 10, okay? Now, is there a point that you know that the asymptotes go through? is there's some point where we know the asymptotes go through. It always goes through the center. So I know my point is -4, -3. Okay, so we could do y minus y0 equals m, x minus x0, and plug in a point that they go through. So this is going to be y minus -3 is equal to 7/10, right? X minus -4. And all we have to do is crank this out and get our y equals mx plus b. So it's going to be y plus 3 is equal to 7/10, x plus 4. Okay, so y plus 3 is equal to 7/10, x plus 28/10. I'm going to say that we're going to go ahead and subtract 3. Right, 3 is 30/10, right? So we have y is equal to 7/10 x minus 28 minus 30 is going to be minus 2/10 x. Put the x here. But we also have the other one, right? We have the other piece. So it still goes through the same point, except we have the slope in the negative direction. Okay. So 4. Let's go ahead and do that. That's going to be at y plus 30/10 is equal to -7/10 x minus 28/10. Right? When we subtract our 30, we're going to get y equals -7/10 x minus 58/10. Oh boy, this is looking too much fun to graph, isn't it? So, right, when we go to graph it, we'll worry about it then. All right. So what's my center? My center was -4, -3. That one's not so bad. Okay. I like how they just kind of guide you through this. Some of these, you have to go through like 18 parts, and then it tells you whether or not you got the thing right or wrong. Now the vertices, right, that was going to be 6, -3, and -3. Get rid of this. I like how boiling water was not, it's going to be too noisy, but laundry is not noisy. Okay, we did that. That was going to be root 149. So that was, oh no, it wasn't. Yeah, it was. No, wait, go back to that. I was wrong. It's from the center. So the center, the x value for the center was 6. No, it wasn't. The x value for the center was -4. So it's -4 plus root 149 and -4 minus root 149. Okay, so make sure we're on the center point. It's root 149 from the center. So -4 plus the square root of 149, and then -3, right? And then -4 minus root 149, and then -3. So when it's offset, hyperbola is more than anything else. It's kind of nice. Like, make sure that you get them centered at the origin. Otherwise, everything starts getting more and more of a mess. Okay, the asymptotes. See, this gets worse. But we figured this out. It's not going to be so bad. Okay, so we have right, y is equal to 7/10 x plus 2/10. 7/10 x. Oops. No, I don't like any of that. 10th x plus 2/10. Oh, might get mad at me for not reading that as 1/5, but, and then y equals -7/10 x. Just not that x. What was that? Minus 58/10. Oops, that one. All right. Crossed fingers. Oops. Wait, your answer is simple. See, I told you I was going to get mad at me. Like, really? Is that a positive or a negative? Let's check that again. It was a minus, 28 minus. Simplest form. I think I did. Oh, okay. Let's argue about it. Next. Oh, what? They didn't give me a little plotting device. Oh, no. All right, -4. Right, -3. Let's hope they're not going to be too much of a pain this time. All right, place the vertex, and that was going to be 6, right? And then place the asymptote. Okay, well, we went up, right? We went 10 points from here. So -3 plus 10 should be up here at 7. All right. Fingers crossed. I didn't like it at all. Okay. What was my y values? Yeah, it was plus or minus. Oh, it's plus or minus 7. Okay. All right. -4, -3. There we go. Vertex was, what do we do? We did -14. And we have to do an asymptote. Okay, so here we go. We're going to 1, 2, 3, 4, 5, 6, 7. All right. Hooray. All right, we're good. All right, I think I'm going to go ahead and stop this here. We did some graphing of these things. We will definitely do some more tomorrow with this thing and graph some more stuff. And we also have to go backwards. Okay, hopefully they don't have any of them that are really off center though. That would be kind of tough. Okay, we'll make sure we do some more problems tomorrow too. All right. Yeah, we'll definitely be doing that. Okay. Identifying which one is which. That's a nice game. Okay. If they have a plus, it's an ellipse. If there's a minus in here at all, it's a hyperbola. If one of the variables isn't squared, it's a parabola. Okay, so we'll go ahead and we'll finish this guy off tomorrow and do that. So you have enough to get started on your homework, probably up to about 6, 7 maybe. Oops. Yeah, we'll do this one tomorrow. So you have enough to get about half of your homework started. So we'll stop there and I will see you tomorrow. So I'm going to stop recording.